the fin whale behind me out on a sandbar. It's huge now because it's blown up with gas. It died 2 days ago, came in from the ocean, and we don't know why, and we don't know what killed it. But you can see people are now making their way over there. We have a window of opportunity of literally a few hours to be able to get out there and start the post-mortem to try and unlock all those clues that are not only going to tell us why that whale died, but also help us understand the whales that are still living out there. And let me tell you, the weather is absolutely abysmal.
On the 15th of January 2009, a fin whale swam into a bay off the south coast of Ireland in County Cork. Fishermen from the village of Court McSherry made valiant attempts to save it, but once the tide started to go out, this 65-foot whale was doomed.
I never seen a whale in my life.
Here was a unique chance to explore the anatomy of a whale and discover its evolutionary story. Why did these mammals live in the sea, and how did they become so large? This adult female was far too big to be transported to the Royal Veterinary College, like the other animals in our animal autopsy series. She weighs about 50 tons, as the local digger operators were about to find out. The whale was decomposing fast, with a growing risk of explosion. The Irish authorities feared this could degenerate into a public health nightmare. The vet in charge, Dan Crowley, accepted our offer of help to fly in the queen of whale anatomy from New York, Joy Reidenberg. In the Campervan HQ, she quickly takes charge of the operation.
As soon as the first cut is made here, that first cut is going to cause a lot of hissing. We make one cut and everyone backs up. If you keep going, or you make the cut too deep and it goes through the muscle layer and into the peritoneum, which is where all the guts are, then you're going to have an eruption like a volcano, and all the guts are going to come right out of that hole, and you're going to see it just spouting sausage links out through a little hole.
In Denmark, they learnt this lesson the hard way. The tide's now dropped, and we have just 4 hours before nightfall.
This is obviously the head of the whale. It's on its side and slightly on its back. You can see one eye just down here. This is its upper jaw. This is the baleen plates. These are made of keratin, like your fingernails, that they're used for filtering out all the food this animal eats when it dives and feeds. This is its tongue, believe it or not, which is blown up because of the gas inside it. Absolutely massive. And you can even see these tiny little papillae on it. It's just slightly rough to the touch. It is extraordinary being this close. It's so sad it's dead, but extraordinary.
Okay, you guys, we need everybody here to be on the other side of that water, because we're going to cut this in and it's all going to pop out. Everybody move, please. Get out of the way, you're going to be coated in whale goo. Okay, here we go.
That are decomposing the organs inside. Even though it's cold outside,
whale bundled up with a lot of layers. That whale's bundled up with its own layers of blubber. I'm going to try to let gas out from as many small ports as I can rather than one large one. Because if there's one large one, all of the internal organs will get pushed out through that hole. The whale part symphony. What's the opening number? So now the inflation has come down quite a bit, so the big explosion isn't going to happen anymore. We've taken away most of the pressure. That part's done. Okay, this is freed up.
Under the skin lies not only the clues to this animal's death, but also the secrets of how the biggest mammals on Earth evolved. Whales remain hidden from view apart from tantalising glimpses when they come to the surface for air. How they survive so long at such depths is one of the great wonders of the natural world. And the story of their evolution defies belief, as Richard Dawkins explains.
All our ancestors came from the sea and obviously went to great trouble to leave the sea and become radically changed to live on land. And then some of them, whales, sea lions, penguins, turtles, went back into the sea, which would seem to sort of undo a lot of hard research and development, so to speak, and need to sort of reverse it. They didn't quite reverse it. I mean, they rediscovered many things. The shape of a whale or a dolphin is pretty much like a big fish. But amazingly, if you look inside, deep inside a whale, you'll find vestiges. Vestiges of hind limbs, little tiny remnants of bones, which show that the ancestors had real hind limbs that they actually used for walking.
Later, we hope to find this vestigial hind leg, but first we need to strip off the blubber.
Okay, you and you, come on out. I want you on this side. Can you use one of the long knives and start the cut that's going above his head? Be real careful in his head, okay? If you need him to move, let him know. The wing is going to pull on that when you lift it up, so be real. You can start with the hand knife here. This line right here. You get to here, you're going to switch to the other tool. If the wind is too strong and it's pulling it, stop. Don't risk it, because it'll fly out of your hands and it'll impale someone. All right, I'm going to go up there in the meantime. Oh. If the no, not that, not that.
Oh, just the hook.
Just the hook. Have you got a hook? If the wind isn't too bad, I'm going to get up and do the cut. I just need to see how bad the wind is. If I feel like we're going to get blown off, I'm not going to do it.
Yeah, they're behind you.
All right.
You okay with that?
Yeah, I think I'm all right. I want to get to that depression where I can sit better.
Okay. Hang on. There you go.
Okay.
Knife.
I need a knife.
Here you go. Come on.
Beautiful. Got it.
Joy's got the most dodgy job at the moment. She's trying to balance on a very slippery whale. She's cutting through the blubber from front to bow, back to front, all the way around, so we end up with one big sheet of blubber that hopefully we can just peel off from the underside like a banana skin, and that'll give us access here to the thorax with the heart and the lungs in it, and then further back into the abdomen for all the abdominal organs like the digestive system, the kidneys, the genitals and so on. I tell you, the smell is absolutely unbelievable.
So I'm cutting along this area here of the whale's belly. We're heading toward the genitalia, which are right down there.
As the team continues to unzip the blubber on the fin whale, more and more people catch wind of the activity on the beach and venture across for a rare glimpse of this giant from the deep. Local businesses are quick to take advantage of the new tourist attraction, while the authorities fight a losing battle, holding back the inquisitive crowds.
The pieces that are kind of hanging off there.
Yeah.
Is that plastic or is it skin?
Hang on a minute. That?
Yeah.
What does it feel like?
Plastic. Skin. Plastic. Skin. Plastic.
So who thinks plastic? Who thinks skin?
Plastic. That's skin. That's plastic.
Okay. No, that is skin. It's exactly the same.
Ha!
It's the same stuff that's on your hands, because you all the time, the outer layer of your skin is growing all the time, and every day when you wash and when your clothes rub on your skin, it comes off. That's where you get flakes. You know when you get dandruff sometimes in your hair, that's flakes of skin, or when you get sunburn, hopefully not, but if you do, when your skin peels off, that's exactly the same. That's just the outer layers peeling off the whale. It's all skin.
Once upon a time, all mammal skins were covered in fur to keep them warm. But in deep water, fur is a poor insulator. So the whale's ancestors swapped it for blubber. But the really big question is why they left the land in the first place.
It's just that animals are going to pick up opportunities wherever they arise. And if they discover an opportunity, like seals just spending a bit of time in the water, otters spending a bit of time in the water, there is a living to be made. They make it, and then once they've gone that far, then there's a living to be made going a bit further. There's a living to be made finally not coming back onto the land at all.
All right, I'm going to make this last cut. It's going to spring down as soon as I do it.
So Joyce is going to make the last cut and it's going to move down in a second. Here it goes.
I'm holding on. Hopefully I won't run.
Whoa, you're right. Drop the knife, you're going to fall.
I need you to take the knife.
Are you okay?
Yep. I got my nice hook. I'm all set.
He's hanging by a thread.
And now I can be Jonah in the mouth of the whale.
So Joyce, this here is all baleen, isn't it? The filtering system.
Yes, that's all baleen, and it's a sieve, like having a big mustache. So the whale is going to take all that food in, squeeze the water out, and the fish get trapped on the mustache. And then it licks its mustache, like having a nice beer with a good head on top, and then you lick it off.
And does it regrow if it does get damaged?
It does grow, just like your fingernails, keeps growing. So yeah, if it has a damaged one, it'll grow it back out.
When baleen whales go in search of food, they prefer to shop in bulk. They eat shoals of fish and krill that can be so densely populated they stain the sea red. To trap this much seafood in one go requires opening the mouth as wide as possible. Unlike other mammals, the two halves of the baleen whale's lower jaw are not fused together. Each side disarticulates, allowing its huge expandable throat to fill with water. As it squeezes the water out, fish are trapped in the moustache-like baleen plates, ready to be licked away by the tongue.
Take a look up here. This material here is the tongue.
So this
is it. This
Okay.
stretchy stuff that you're looking at here is the floor of the mouth.
right.
That's actually the tip of the tongue. Okay, there we
Here.
go. There we go. That's it.
Okay.
That's all there is. This is it.
That is the tongue.
That's the tip of the tongue.
So most of this
Most
that
of-
was blown out the front that I thought was the tongue is actually just the floor of the mouth.
And some of the tongue.
Okay.
Some of the tongue was, because this was up there.
Wow.
Now it's all retracted because this is very elastic tissue. So once the tension was off, it all pulled back this way. You see,
Yeah.
it's very floppy. It's not a lot of muscle in there, but there's enough muscle to cause it to curl, kind
Yeah.
of like this.
Yeah.
And when it makes that curl, as a baby, these little fringes, which are actually a little bit bigger in the babies, help like fingers to grab around the mother's teat to form a tube so that when it's nursing, the water is channeled through that tube and into the mouth so the milk is not lost to the ocean.
And so far, have you found anything in terms of any possible reasons for death?
Not yet.
I can't believe that you are inside the mouth of a whale.
Okay.
There you go. I don't want to lose you inside
I know,
it yet.
it's
There's
really
still a lot of work
Not
to be
yet.
done. The digger's just being manoeuvred into the right position now to be able to have the right angle of pull on this blubber, because ideally what wants to happen is rather than trying to pull it out at right angles to the body, it wants to pull it longitudinally, like just peeling back that banana skin. If the rope pulls through, the only alternative is with us with knives is to actually hand cut it off, which will take probably an hour and a half. And the tide will be on the turn and coming in any moment, so that would be a serious disaster. This is going to be dramatic.
Go for it. Here comes the rain, right on schedule. Perfect. Okay.
With the blubber coat peeled off, we can finally investigate the internal anatomy, and we'll begin with the guts. Their contents may yield vital clues about what led to this animal's death.
We're about 2 hours into the dissection at the moment, and what we're trying to work out now is how to get the small intestine out of the abdominal cavity to be able to drag it away. But the difficulty is trying to, not only is it heavy, but I mean typical of intestine, it just wraps in amongst itself. What's amazing is it's still so warm.
I guess everybody stopped breathing through their nose in the last while, huh?
You need one of these to get it out. This could be very messy.
We need to do something to get it away from here, because when the tide comes in, it's going to sling it all
We're
around.
organising our container to take that and all our internal organs, right? Store them up at the shoreline.
Okay, look how much we got done so far. It's not sunset yet.
Joy is on her own race against the tide. For her, the holy grail of whale anatomy is understanding how whales talk to each other. And there's a vital bone called the hyoid that she's determined to reach by diving down the whale's throat. It looks just like a wishbone in a chicken, but pulling this wishbone out of a whale is a much meatier challenge.
The hyoid bone is a free-floating bone in the neck. It's not really attached to anything else in humans. In whales, the hyoid bone is attached to the skull, so this is going to be a hard bone to get out. Can you pull it down now? This is the epiglottis. It's the beginning part of the larynx. The larynx is the voice box itself. That's where the sounds are produced. And this bone is still attached to the larynx, so when it moves back and forth, it moves the larynx as well.
The songs of whales are so deep, they're beyond the range of human hearing. It was only during the Cold War, when the US Navy took microphones into the ocean to listen for Soviet submarines, that they inadvertently became the first humans to hear them. But what are they saying?
Well, they might say, I found a really cool patch of krill, come on over here, it's a food fest. Or they might be saying, Mama, where are you? Or they might be saying, I'm sexy, come mate with me.
The puzzle for Joy is how a mammal's voice box modified to work underwater. She has her own theory, but she needs to dig out the larynx first. As the sun sets and the weather turns bad again, the odds are not looking good.
Mother Nature is definitely taking hold of our dissection now. This is an incredible hailstorm. It really hurts on your face. And the team are trying to tidy up and move as many of the samples they've taken out of the carcass into safe ground, because obviously the tide's now coming in. Poor old Joy, she's still battling away to try and get that hyoid bone and the larynx out. And just where the digger bucket is now, they're just trying to excavate out the liver, because they've had enormous problems trying to get that out, to get access to the diaphragm that separates the abdominal cavity and the thorax or the chest, because if we can open that big curtain of muscle, we'll get to the heart, which is hopefully what we'll do tomorrow. We've got to be leaving soon, because otherwise we won't get off this beach.
At last, Joy wins her tug of war with the monstrous wishbone. But the hyoid snaps off the larynx. One last shove and the larynx will be hers.
Easy way down. All right, that's it.
Despite driving rain and fading light, Joy cannot resist an impromptu tour of her favourite organ.
That's the voice box, called the larynx. This is the front end. That down here is the epiglottis, the front part of the larynx. It's a little bit shredded right here. That's the opening in that air would take to get into the larynx. These are the corniculate cartilages, and they have these interesting flaps on them, and it's not clear whether these animals pulse these flaps, because fin males actually do make pulse sounds. So these might be part of the sound producing apparatus. If we follow the air through and go around to the back again, where it's coming out in the back right here, you'll notice that as you look through that hollow space, if you can see the light coming through, where I'm putting my hand, the sac is probably responsible for bringing those sounds out to the outside world. So this sac can really balloon out and take a lot of volume in it. As this bag distends, it pushes on those throat plates, which are like an accordion. They can expand and contract. And that in turn would send the pulse into the water directly. And these animals are making low frequency sounds, so the bigger this is, the lower the sound.
Oh,
I knew that was going to happen. There it goes.
Tell you what a difference 12 hours makes in the weather, though. Hey, unbelievable. Should be a very good day today, I hope. It'd be great to try and find the vestigial hind limb, which would be good. It's female. It's even a possibility it might have been pregnant. While we're waiting for the tide to go out, the job we can do now is all the bits we harvested yesterday, the digestive tract, the intestines. We can have a detailed look at that. A bit of tape around the top, please.
Lovely mist.
Do you get used to this smell?
Oh yeah. This doesn't smell nearly as bad to me as simple things like, you know, changing a baby's diaper.
Before we can find clues about its last meal, we need to lay out the tangled mass of guts.
Somewhere underneath here is the stomach, which is the beginning of the tract. So we need to flop some of this over to get down to the stomach.
The intestines are over 80 metres long, 4 times the length of the whale.
The food is coming in through the stomach, which is all the stuff on this side of me. And then it's going to run through the small intestine, which is this stuff that's looped back and forth all the way down the tarp. And then as it comes around the corner down to the end, that is the large intestine ending up at the anus. And this is a meal from before the animal became stranded. And we see what's coming out on the other end of the animal. This is poop for a whale. But it's pretty wet stuff. It's a lot wetter than what you expect on a land animal. For a whale, it needs to have something it can excrete while it's still moving and swimming.
Joy now wants to check what it ate just before it died.
This is stomach.
Okay.
This is a really large, so we can pull it.
We need a bit of help here.
There you go, hold on.
Let's make another hole. Here, here's one right here. Pull it.
We can pull it this way, we might do better.
Perfect. We're looking at the beginning of the stomach, one of the chambers of the stomach here. If the animal had eaten, this is where we would first find food. But we're not seeing anything in here except fluid. So this indicates to me that the animal was probably sick because it wasn't feeding. This would be the next chamber. Want to get a sample of that?
Even though they are fish eaters, bizarrely whales have a multi-chambered stomach, more suited to a cow.
Amazingly, whales actually belong in the group called the even-toed ungulates. That's the cloven-hoofed animals. Now, one always knew that there was some connection between them. But what was astonishing was that molecular biologists showed, looking at DNA, that whales are actually closest to hippos. Hippos are even closer to whales than hippos are to pigs or cows or any of the other cloven-hoofed animals. Now that's an astonishing thing.
65 million years ago, the sudden extinction of the dinosaurs opened the door for mammals to become the new giants of the planet. One species that survived spawned the evolutionary pathways that led to over 200 modern plant-eating animals. But one of them came across a new opportunity at the water's edge. This was Pachycetus, the first whale. It had sharp teeth that allowed it to hunt, and then gradually its legs shrank. Over 50 million years, it went from the size of a dog to the largest animal that ever lived.
It's interesting, isn't it? Because you tend to think about the fact that, you know, everything we've talked about with the whale is that it's perfectly adapted for its environment, but actually it's got all kinds of handicaps associated with the fact that its ancestry was on land.
Right.
So it's still not perfect by any means.
You know, if evolution were intelligent, we wouldn't have these handicaps. Yeah. It's not. It's a mishmash. It's a patchwork. Every time you want to make a better mousetrap, you put another patch on. You have to work with what you've already inherited. You always have evolutionary baggage.
Makes you think though, doesn't it, in the very long term, in the future, would you end up with this evolving into an animal that then moves more to being to having gills or being able to actually extract oxygen out of the water rather than having to breathe like a land mammal?
You could never make those predictions because evolution isn't directed.
Yeah.
And you never know what the environment's going to do because it has to respond to how the environment changes. Who knows what changes are going to happen? Maybe global warming will cause our whales to evolve into something else.
When whales took to the water, their swimming style was set some 50 million years ago.
Their ancestors used to gallop over the countryside. Now they live in the sea. In a sense, you could say they gallop through the sea because the spinal movement of a whale as it swims through the sea is up and down, which is similar to what mammals do when galloping over the land, unlike fish, from which they're all descended, where the spinal movement is side to side. And at some point in the history of mammals, they must have switched from a side-to-side spinal movement to an up-down spinal movement. And the whales, then, even when they went back to the water, retained the up-down spinal movement.
Galloping in the sea didn't just mean swapping legs for a tail. Joy thinks the hyoid bone she extracted yesterday from the whale's throat may hold the key to how whales swim.
Just like a human swimmer might do the dolphin kick. You know, the dolphin kick isn't just kicking your feet. You have to have a whole body wave that begins with your head and moves up and down. So the initiation, the beginning of that swimming motion must start with the head pulling down and then up. The only thing that can really pull the head down is the muscles attached to this bone. Because the attachments that go from the chin to this bone, in turn then go to the sternum. That's the beginning of the rib cage. And when you contract all of those muscles in a row, That means the hyaloid being caught in the middle between those muscles is going to be responsible for bringing the whole head down. So if the animal keeps its jaw closed and then contracts those muscles, instead of opening the jaw, it's going to depress the head. And that's the beginning of the body wave that these animals use to swim. So that makes this bone a bone that's involved in swimming. And that's unusual, because here's an animal that's locomoting with its throat.
Joy's research is turning the science of how whales swim on its head. By studying a bone crucial to communication, she unwittingly stumbled across an explanation of how they learn to swim. The fin whale is the greyhound of the sea. Its streamlined body crosses oceans to reach its feeding grounds. But in the case of our whale, something went wrong when it came to feed off the coast of Ireland. Now the tide has receded, we have just 4 more hours to try to solve the mystery. Preliminary evidence suggests the whale was sick, but Joy wants to rule out another possibility, that it was hit by a ship.
Boat strikes tend to be marks that go this way. So I'm looking for a big area that looks like it's been hit this way. This is a possibility right here. Unless they did it with that scraper. I have to ask them, because this looks very fresh. This is an old injury that's healed up. You can see that the skin is absolutely smooth here, but you see color differences. They don't match up. So this animal had a gash here. Could have been a shark bite, could have been maybe a boat propeller. So that's not the cause of this problem, but it's an old injury. Oh, yes! Thank you. There's a scrape on the side and the blubber there that's in a vertical line. That we think might have been caused by the excavator.
Yeah,
we want to make sure it was.
Yeah, yeah.
Okay, that's good because that rules out one of the possible
because we were
causes.
turning it over.
Okay.
So we don't.
So that made that strike.
Yeah.
So that takes care of us figuring out what that line's from. Thank you.
Having inspected the entire whale, Joy is now confident she can rule out a ship strike as the cause of death. No other wounds that you've seen on this side now?
Just parasite wounds and small things.
As this whale is a mature female, Joy wants to check whether she's carrying a calf.
But somewhere in this big clunk of tissue, I think we're going to be seeing the ovary. It would be an oval-shaped structure, probably about that big. I was hoping it would be in here. This just seems to be fat as far as I can tell. So I'm going to keep looking.
The anatomy of whale sex is extraordinary. Males can have penises up to 3 meters long, and hidden under their blubber, their testicles can weigh a ton. Joy could find no evidence that this whale was pregnant, but back in her lab in New York, she showed us a fin whale fetus from another post-mortem.
And we can see the front of the animal's head right here. If we open the mouth, and we can because it's so flexible, because the bone is still cartilage, it hasn't turned to bone yet. This is all cartilage in here. We're bending open the mouth, and we see this. This is the tongue. And these ridges are where the baleen would develop. And the animal is folded quite compactly inside the womb, like this, in a very compact, streamlined form, just like that, all folded together. And when the mother delivers the baby, you usually deliver them tail first, so that the animal doesn't take a breath until it's actually outside the mother. And then after it's born, it will swim to the surface and take its first breath through the nostrils, which are on the top of its head.
After taking a breath, some whales can stay underwater for half an hour or more before returning to the surface again. Their lungs have adapted to refresh 90% of their air with one exhalation. Now we want to reach the lungs and heart in the last remaining hours before the tide comes in.
How confident are you that we're going to be able to get into the chest cavity?
I keep my spirits up. I think we can do it.
The heart and lungs are encased inside the whale's vast rib cage. But because a local village wants to preserve the skeleton, Joy can't saw through the ribs as she originally planned. So she has to dive under the rib cage to try to release the organs.
You can see now here, Joy's just pulling out, or some lung has prolapsed out from the chest, which is the light-coloured pinky tissue she's working on now, but she's trying to cut the rest of the diaphragm away because we want to be able to particularly look at the heart that's inside.
Brilliant.
Hopefully in a few minutes, if we can get through the diaphragm, we might actually find it.
Brilliant. Good.
This is the aorta, and this is the major blood vessel that's carrying blood from the heart down through the rest of the body.
Where have your legs gone?
God, don't even ask. I'm so messy now, it doesn't matter anymore. Heart is right in here where my hand is reaching. That's the heart. So I can feel it, but it's so large I can't pull it out until I can free the top, and I don't know if I'm going to be able to get in there deep enough to do that. But I'm still trying.
The heart is held in place by massive blood vessels that are just too deep inside for Joy to reach.
Alright, I won't be able to get the top of the heart. It's too far up to cut those. The only way we're going to get that is if we cut the ribs now. It's too much. But I can tell you how big it is. The heart is, bottom is here, and the top of it is about here somewhere. So it's about that wide, about that tall, and about from here to about here in width. So we're talking about something that's about this big.
When the whale is underwater, the gigantic heart pumps as slowly as 3 beats a minute. The lungs can inhale 2,000 litres of fresh air in a single breath. That's how whales can spend so much time at great depths.
Down. No. Straight back. Nice and slow. Hold it there.
It's getting quite frantic now because we're losing the light, and they're trying desperately to be able to take the bones, the skeleton out of this to be able to save them. And they've currently got the lower jaw, they've taken it off at the hinges back here where the other digger bucket is, just about a foot the other side, and they're going to pull the whole thing out forwards. It's a huge, huge bone. It's this bit here under us.
Wait it up.
But they're going to lose the light. They are going to lose the light.
Right the way up.
While there's still light, Joy wants to examine the anatomy of this whale's senses to see how they work in deep water.
Okay, this is the eye of the whale. We're going to cut the lids. This is the lower lid because the animal's lying on its back, and this is the upper lid, and so we're going to cut through this, widen that passage, and then cut the eye out. We have to cut it from all of its muscle connections. And then let's see how interesting the whale eye is. Because it's adapted for seeing in water and dealing with high pressures of diving. We're almost there. It's about to come out. Here we go. Now it's hanging on just by the nerve in the back that transmits the image back to the brain. We're going to cut it right down the middle now to show you the anatomy on the inside. This is very thick and therefore very hard to cut. It's really solid with connective tissue. So if I try to really lean on it, I'm going to lean on this and push on it. I've got all my weight pushing down on it right now. And all I'm doing is squeezing the blood out of that muscle, but I'm not able to deform that eye. It stays in that shape. It's a very, very sturdy construction. Now, lens is really interesting. Okay, we're going to put it on the eye for Irish. See how much bigger the eye looks now, that letter I? Because the lens is actually magnified.
Tiny lens, isn't it?
It's still, yeah, it's actually, it's really not a lot bigger than what you see in the cow. It's bigger, but not by a lot.
Even though whales' vision is very limited underwater, when they surface, being able to see has definite advantages. Especially for killer whales hunting their prey. But when whales dive into deep water, they have to rely on other ways of seeing in the dark. They use sound waves instead, listening for echoes bouncing back from sounds produced in their voice box. High-frequency pulses can pinpoint the precise location of a fish, which is particularly useful for killer whales and dolphins. But for fin whales, it's the low-frequency sounds that are important. They pass straight through small fish and travel much greater distances to reflect off shoals. This allows them to detect a school of fish a mile away in only 2 seconds. Joy has been working on the head and has managed to dig out the ears that hear these low-frequency sounds.
So here we can see the ear attached into the skull. It has this soft finger here, which is called the glove finger. It looks remarkably like my glove finger, doesn't it? It's even soft, you can push on it. And this part here is probably the remnant of the eardrum. The rest of this is bone. And inside here, there's more to this ear, but it broke off, and that's still in the skull. And inside here is the hearing apparatus.
Whales' ears also use echolocation to map out coastlines. So did this one know where it was going when it came into shore?
An animal will seek a shallow place to rest because it has no energy if it's sick. But when the tide goes out, gravity becomes a factor, and now the weight of the animal crushes its internal organs. It probably died from suffocation, from its own weight crushing. It probably was sick, which is why it came in on the sandbar in the first place.
Just as we're about to finish, one of the team makes a discovery.
Okay, let's see what you got. You got it, yes! It's definitely it! Rope. Okay, nice. That's definitely it.
It's the vestigial hind leg, the missing link to a life on land.
So this is an indication that these animals evolved from four-legged terrestrial animals, but they've made their hind limbs so small that they're embedded into the body wall now. They don't stick out as hind limbs. So what we're seeing is just a little remnant of the thigh bone.
That leaves one last question. Why did whales grow so much larger than their hippo cousins?
I think it's something to do with being freed up from the constraints of gravity. A land animal has an immense weight to carry about, and big animals like elephants, for example, have great tree trunks of limbs. Whales freed themselves up from that. It's almost like going into space or becoming a balloon floating through the air. They are no longer constrained by gravity. They're supported by the water. It then becomes possible to become more or less indefinitely large.
Well, it's been an incredible 2 days here battling the elements in Ireland, trying to learn as much as possible about this poor dead whale behind us. In terms of why it died, we've got lots of clues. We think it had an acute illness and for some reason ended up in this bay and got stranded. And it's one of the Achilles heels of whales that when they do end up stranded, essentially they suffocate because they simply cannot breathe when their body's not supported by water. The most incredible thing for me, though, is the fact that seeing a whale from the inside proves to you it's a mammal just like us. It breathes air. It's got the same kind of body systems and organs, yet it's adapted to live right out there in the ocean rather than here on land. An amazing thing, that animal is more closely related to a mouse than it is to a fish.